Craig, how are you? Are you rolling?
I don't understand. Yeah, you're right, listen. Okay, I'll kick it off. Okay. Good morning. Our presenter is Jesse Hughes. For the past 2 decades, Jesse has incorporated space assets, imagery, and architecture to solve problems on the ground, where he spends the majority of his time. His professional background runs the gamut of operations, professional services, strategy consulting, and business development in both private and public sectors. He is a graduate of Booth School of Business, a space operations officer in the U.S. Army Reserve, and a father. Please join me in welcoming Jesse to the podium.
I'm more of a pacer, so I'm gonna walk around a little bit. Hope that's okay. If you can't hear me at any point, just raise your hand. I do have a question to start off though. What is scuffing or a scuff or when something is scuffed? I've heard it like 3 times here and I have no idea what it is. Sorry. Okay, so when you scuff something, you're. I am here. So I have a lot of questions. Space is new. I'm looking for questions that we about me. If you're here to learn about our scene for the first time, we just rebranded. Rebranded yesterday to the website. And our full logo, you're gonna want them. Because when we're rich and famous and big, and everyone's like, I saw them back in 4C in 22. You prove it with the old logo, or it's the last thing you'll receive from us because, like a San Francisco-based startup, will just create right? Okay, one of the two. It's either a long guard or it's very cool. All right, with that, space. Just help me understand a little bit of the room here that's dealt with space, their job and their personal hobby, anything. Okay, fair enough. All right. Who's used a space-based asset before? Everybody. Why?
We're evaluating this technology.
Okay.
How do you find it faster? How do you kind of?
I'll do this. I saw another hand. Supposed to use space. GPS. I'm sorry. Every day we use it. GPS probably watch, right? These are things that we are ubiquitous now. You take them for granted, right? But I remember before GPS was a thing, mapping, compass, all that stuff. I started my professional career in the Army infantry. And now I find myself dealing with space. Yeah, use it every day, but not just, that's our direct use, but those same GPS satellites, and we'll get into in a little bit, they actually, the magic of GPS, it's a timing system that actually synchronizes all the SWIFT networks. All of that's operated off of a GPS constellation, 30-some odd satellites. Cool. This is off of Leo Labs. You go on leolabs.com, and it'll show you everything that's tracking on orbit. I've got it color coded by country of origin, so you can kind of get a sense for the flex there. The big bursts are actually like a space fence radar that's tracking these things. You can toggle those on and off, play with it. It'll show it in real time. You know the name of the satellite contract, pop in, and it'll show you that one. Mentioned before. It's fun. It's a fun tool to get on. I point out that this is not the scale. Right? There are no satellites the size of New Jersey. That's what they look like. Satellites. International Space Station are pretty big. It's definitely that. Space is not intuitive because none of us lived there and weren't raised there. Right? You're standing on a rock. It's whirling around the sun, breathing a gas cloud that's held to that rock gravity. The higher you get away from out of our gravity, well, the thinner that gas cloud gets, until it's negligible for resistance, and then you can put stuff on orbit. That's what an on-orbit platform is. How far away from Earth it goes was off by a little bit. That matters. It's orbital change based on how far away it is. Get that a little bit, but again, no questions off the mark here. Just to give you a sense, a total eye chart, I acknowledge, over $4 trillion is the estimated size of the space industry, and it's just something that's happening now. Here they break down by the different, not only the space ecosystems, but also the subsystems that might support it. So you get a sense for nanotech or drones that can also be in as a system of systems in the space. But you get a sense for how much government organizations are in, and the investment pool has gotten huge compared to the government side. You know, government spending is still big in space, but it was dominant in the 80s and 90s, and now it is reversed. And so the commercial world has really captured that. Another pivot in perspective. Take a look at US, Canada, and then if you were to add up all of Europe, you end up with about 56% of the space market is found US, Canada, and Europe. That's a pretty stable supply line and ecosystem. Some of the other big players don't have that interconnectivity. There's a lot of advantages for us. And I'll talk more about it. But just to give you a sense of scale of kind of what the environmental ecosystem works for us. And this is government spending. US government still the single biggest government spender out there, and that's not particularly surprising. If I go too fast, or I'm happy to provide copies of slides afterwards too, sir. Okay. Why do we care about space? I'll still give you. All right. It's all about the data. Who said that? All right. All right, there we go. Good. It's all about the data. And there's 3 missions in space. First mission, Earth observation. This is the one that, your Google Maps is showing you pictures of satellite that they're. That's probably the one. Right. The one Zillow to see what your house is worth now. Earth observation. Infrastructure. This goes to the GPS that we were talking about, which in space nerdery is position, navigation, and timing. Systems. GPS is not the only one out there. Europe has one called Galileo. The Chinese have one, Beidou. Russia's got almost global. India and have augmentation GPS that ride on the backbone of augmentation navigation. Which and it also gets communication satellites, right? So think HughesNet, right? You guys seen those fishes on the side of houses. Deployment satellites. So those communication birds, they're about the size of a school bus, they're pretty big, and parked pretty far away from the station. But that's all part of the infrastructure. How we're using space for. The third category is kind of new and up and coming. That's space for space purpose. How do you refuel satellites? How do you clean up space debris? How do you manufacture on orbit so that you can do that outside of Earth's gravity well? What does that change in the space environment? So that's kind of a new thing. And this one you'll start to see way more. That just this year, the first on-orbit commercial blanking on the names. But cool stuff. We can actually meet up with a satellite on orbit. Now that extends the life of that satellite. Okay, we're going to talk Earth observation though primarily today because that's most of what we care about here. And when it comes to data, we're going to follow just this is not my intelligence processing data. So borrowing this from the Intel. 5 stages: collection, processing, analysis, dissemination, and then it goes back to the bidders. Planning, how do you know what to do? With that, I'm just going to look at these 4 pieces of it. We won't go into planning because that really depends on you and what you want data to do for you. So first, collection. This is where the economies of scale have really changed in the last 5 years. On the left, you got WorldView. Really cool console. Satellite, we did 1-year resolution. Super expensive, $680. It's a custom built satellite that was giving you really good, very good visible spec. 2014. Less than 10 years. In 4 months, we put up the first 2 satellites in our constellation. Getting pretty hyperspectral. Putting off commoditized satellites. Less than 5 minutes. Everything you see on WorldView had to be designed especially for WorldView. Because at the time, there was no commercial off-the-shelf. Here's what a satellite chassis will look like. Here's what a satellite navigation system. Here's what a satellite, control system. Every single one of those components had to be custom built. Now, we're not building the entire satellite. There's somebody selling us the chassis. There's somebody selling us the control system. There's somebody selling us the solar panels. We're slapping together, and the piece that's unique to my company is the optics. So that's the one piece you've got to worry about. Everything else is available, like Henry Ford assembly, which is why the cost is coming down. Launch costs are part of this as well. I'll show you a couple. SpaceX and others are doing what's called a rideshare, where you're going to launch on a SpaceX rocket will be one of 30 satellites going on that rideshare. So I find a bus ticket, they tell you the orbit it's going to, you sign them up, they'll tell us when it's launching in October. And when it gets to that orbit, just start talking about it. It's made the cost of accessing space affordable so that you can use it for commercial applications. Okay, jump into processing, this gets data analytics. Satellite orbiting over Earth, taking pictures, it ends up in this visualization. But there's some anomaly tenants, so you gotta georeference it. System. Then once you get there, you gotta georectify it. So then there's an orthorectification, where it looks at topography, right? So looking downslope of a mountain or upslope of a mountain. You gotta get all that right so it's not distorted. This is the most boring slide I had, but many thanks to Gabe Latin to try to put it together for me and had to teach me this stuff. With that data, now what can you do with it? This is where data gets important. Where data, all about that, and analysis on it. So what? This is an example. Using here we're doing near infrared waveband against red reflectance for crops, just to show, hey, here's crop health application. So that you can then say, we need more water into this field. This field, not under fertilizer. Now you can redirect finite resources to agriculture. Address that. That is an example, and I'll show you more in my perspective. We'll get into something around data coming out of it. I feel like I'm rushing through stuff. Everyone, still on pace. Okay. Now to the data dissemination. And this also, I'm seeing a lot on the floor. I'm just trying to figure this part out. How much are you seeing? Analysis paralysis. Everyone's about the platform. And how do you get it so it's into the operators? That's a trick. That's not easy. Google Earth has figured it out. Everybody here who has a kid knows how to use Google, right? And every kid can figure it out in like 5 minutes on their phone. Walking around with a stylus, off the finger, point to the screen, and they can figure out where they are in the world. So Google Earth has done a great job. Very quick and very intuitive. But you can't get a lot of granularity. That's where ArcGIS and GIS platforms got other software built on top of them. So you get somebody with a master's degree, really cool stuff. Takes training. So somewhere in here is the right mix for your particular business. Need it so intuitive, there's no training for it. Or are you so data heavy that you need the advanced data analytics? Dissemination has to support data. Now I do put it to the room and show of hands. I've got two directions. We're going to cover both topics. Which one do you want to do first? Methane detection, involving storage, or what about the cool stuff, the rockets, the kind of show of hands for methane. All right, fine. Good. Our hands for rockets and nerdy stuff. All right, let's say 200. Cool. We're going to rockets. That was a quick count. Sorry. Just quick. Orbits. Awesome. Orbits matter. Two examples here. Basically everything else is variation. Start on the left. Polar orbit, meaning that the satellite is orbiting. Oh, sorry myself. So again, it's starting the army. Like a circle. Nothing exists outside of 300 meters. Leave the army, go up, back in reserve, and we need space operations. Go up this class. I'm in the back of the class, I'm the army guy, the rest are Air Force, Delta Space. Now, day one, they're like, so here's what orbit means. It means it's launched so high up that it's falling, tries to hit the Earth, but it's so fast that it's missing the Earth. It's constantly falling around the Earth. I freaked out in the back of the classroom, like, no one's flying these things? How come no one's panicking about it? No one's flying. They're just falling all the time, right? And turns out everybody knew that except for me. Actually, I didn't. So these are just falling around the Earth. They're never hitting, constantly falling. They're doing it fast. So in a low Earth orbit, like what you're going to see on the rocket, it gets around the Earth about every 90 minutes. International Space Station, 90 minutes. Whole circulation around the Earth. Polar just means it's going from pole to pole. The Earth is spinning underneath. Another way to think about that is the satellite's always got its back to the sun, looking at the Earth and like walking over it as the Earth goes around the sun, but the satellite's back to the sun all the time. The Earth's spinning underneath. So it sees different spots of the Earth always at the same time of day because it's always keeping it back to the sun. So far? Now, almost a opposite idea is the geosynchronous. These are really far out in the synchronous orbit bells, so that they are falling, they're orbiting at the same rate the Earth is revolving. So that way, you can kind of see the yellow splotch on the Earth. That's the satellites near the Earth. It's falling at the same rate the Earth is rotating, so it's always seeing the same spot on Earth. Another way, when you're on Earth, the satellite is always in the same spot. Which is why the HughesNet radar, or the HughesNet antennas mounted on a house point in one direction. Satellites that are always in that same spot. With me? Certainly. Yeah, it's about that. Yeah, yes. No, 22 miles, sorry, no. Geosynchronous is much farther up. Yeah, when you're talking, so low Earth orbit, you're looking at like 500 kilometers. It's 23,000 kilometers geosynchronous. So it takes a lot of gas to get a satellite out there. And that also plays into the rocket size. So you do a much smaller rocket to get into low Earth orbit. And because the satellites have to be a little bit beefier out in geo, power a signal into the Earth, you're having a bigger satellite to get there. Those are the big ones. Whereas SpaceX can do multiple small satellites in the low Earth orbit. Other questions? Okay. kind of gave away why we use these. Geosynchronous, good for communication. Go out and set up a radar dish, be a small sat terminal, look at the same spot in the sky. Low Earth orbit we talked about for observation. Some of the paradigms getting up, shifted around. Starlink. There was Starlink. Yeah, that's doing communication from low Earth. Think about the challenge of that. These are the satellites that's only seeing the spot on the Earth. It's going around the Earth every 90 minutes. So it's only seeing your spot on the Earth. It's got to hand off the signal to other satellites. That whole mesh is going on. So they got to bounce between each other to keep you and the user on Earth in the plug in. Okay. Earth observation, predominantly polar. Don't know the video loaded. This is a YouTube video from last Friday, April 1st, was SpaceX transport. They punched out over 30 satellites, which by now is beyond. Everybody knows that with this particular stage, it was like space launch. Just incredible. And it's one of the transporter missions that we're going to use in October. Sorry. But YouTube, Transporter 4. This is from Transporter 2. SpaceX has done is smart. Basically said we'll launch 3 different size satellites. There's the connector ring, standardized. Small connector ring. Satellite cannot exceed this dimension or this weight. Slap on this one's going to have a ring of small tube. Modular sense. Sell tickets on the bus. Modular size. Really smart. And just again, driving down launch costs. Remember when it blew your mind at Amazon Prime with delivery? Remember when you're like, what? There was shipping costs. They're talking about that for space. The launch will be negligible. Mind blowing. There's a launch boost fee $1. Okay. Well, a little more nerdery. Hyperspectral. What is it right now? Yeah, we're talking on rideshare in the hundreds of thousands. Orders of magnitude, just dropping. Yeah. Hyperspectral. I know you've seen it out there. Anybody never worked with it? All right, in the 80s, it was the domain of governments only. Super expensive, super easy stuff. Custom build. Like everything technology costs. Hyperspectral, we're operating from ultraviolet to infrared. Everything. Phone takes a picture, it takes a red and green, blue, RGB. Pixel has an RGB. So that you see what hyperspectral gets 400 to 500 days. Why do we care? Different things give off different signatures. Mostly not. When you're running a full data cube like one of these, you can query that data. Methane production. If you're grabbing the entire data cube. So I'll show you a slide where we're talking about what different signatures might happen with it. You can see some of the applications. Chemical detection, hazardous waste monitoring. You can do the look and after the look, so you can. There was none of this prior, and now it's all there. Cleaned it up. It's all gone again. So there's a lot of same technique. Regular. top left is soil moisture sensing. But that goes back to the agriculture piece. Yeah, so we talk about sustainability a little bit, agriculture, mining, oil and gas. And really think in terms of operations, during operations. Using that data to benefit your. And you can start to see, again, you're seeing stuff in hyperspectral you can't see in other things. Underground gas stations. Having to see it. I see a pressure drop on. Start to see see the impact on plant area. You can see fire. Sections of the same shot. Start to match. This is a good example. Here's your standard anchromatic shot. Showing it black and white, but it's not clear. There's different things our data analysts. Okay. Questions on the space nerdery and the nerdery stuff? Sir.
I read something.
It is absolutely. Tragedy of Commons. Space, yeah, air. These satellites. Some of those are not under anyone's control because free or dead satellite. And those things hit a conjunction. Generates more debris. This stuff's moving at 17,000 faster than anybody. It's something that's catastrophic. How do we this? So things like there are companies that makes everybody nervous because it comes with satellite that debris. So those companies get looked at a little bit. But being a responsible custodian in space, our FAA requirements. So that's one of the things they put on. Got to show up. So we're trying to figure out how to. So as we're putting up in low Earth orbit and we're expecting just because of the saw that Starlink. One Starlink. Sun. So there's a lot to. Also some stuff around launch, right? Satellite decouples from the school wave was popping. They had all those faults. Now they're looking at fire and wax, so the wax melted. So that nothing is. It's a great question. It's a great pervasive problem. Not the point it's not solved. Yeah, no, you're 100% right, right? We're gonna get that, you know.
I was just gonna say, the other side of that too, is how all the things in space are like they're impeding like astrological things and like, you know, not being able to things with our that. So like, I mean, I'm not in this space at all, but it's just like curious to me, you know, what conversations are happening, or like, are these people trying to come together to come through? We, you know, want to be able to send space like that.
Yeah, fair. Anybody seen a Starlink launch? Not the rocket, but the satellites. Go outside right after the. So satellites don't have lights on, right? No light on the satellite. But if you go outside right after sunset, so the sun is down for you, but it's still shining and hitting objects in low Earth orbit, you can see reflection off the satellites, and it's like stars moving really quick, really fast, right? And the Starlink ones will be online. Like right after launch for a couple of days, they'll want to space them out. They're a uniform distance, but they're visible in the night sky. And it's cool. Talk to my buddy about it, because I know they wrecked my view of whatever he was looking for. Maybe it's really bad if you're in the research side. High-end telescopes that are taking in the shutter speed super slow because they're going really low light. Also, make it great for just ruin the straight out. Enough of that is a problem. SpaceX is putting on low reflecting paint so that hey, trying to minimize that. Is it working? Moderately, right? Certainly in VR camping, but it is an issue people are trying to figure out. How do not clutter the next game? What's the mic portion? So all things we get to solve, you know, new things to solve. In the 80s, no one. Any other kind of space works. We're under no time pressure either, other than by, you know, your natural inclination to go get lunch. So I'm happy to hang out too if you have questions on chat. Okay, into the methane piece. Got a little more in methane on the slide. This is going for hyperspectral, where you're seeing the absorption rates. Here's the radiation band for you can see methane. Take a picture in hyperspectral, see what's reflected out, and picking up these different temperatures. We've got a couple satellites up doing it now. This is the European Space Agency, 2009, I think. Putting this up just to give you a sense for 2009. And it really kicked off 20 years. Look at the pixel size. That's a K in front of the M. That's kilometers, right? Back to not the best. Anybody from New Jersey? Sir, this is the size of New Hampshire. Anybody from New Hampshire? This is, we're talking massive pixels, right? You can get a general sense of like something's going on around the corners. Right? I'm seeing you look at countries, but not really much better, but it gets us started. So I'm not trying to knock it because it's really an early stage attempt at this and it's a government subsidized. Then you can start getting into a first methane single detection on the satellite. You can see the pixel size now. You're down inside. Probably so far. going in one direction. It's a little bit of egg on face, but you can get at it faster. Now you can actually use a satellite, because remember, they're going over the Earth every 90 minutes. Doesn't mean they're seeing that same spot every 90 minutes. It means they're checking the whole Earth every 90 minutes. One satellite, constellation, can check the spot faster, working together. This is a for where methane's coming out of. Sorry?
I said, can you like Google that and find that?
Yeah, that's this is the European Space Agency Sentinel 5P, 2019 came from. So, absolutely. That name is that's not going to be specific. So, with our sensor, we cattle, who's a big, oops, there's a dairy farm right there, you know? So with satellites, you can start picking up stuff in places you don't want to go. And this is a French agency picked up something in Iraq. No reason to get out there and don't want to put somebody out there you don't have to. Years ago, oh no, I'm sorry, 2021, last year, that was a pipeline leak in Iraq. But you don't need to be that nice. And this is one from Turkmenistan again, borrowing PhDs. Their iris. I think I saw in the booth, they've got another one going on. This year. Their resolution. A little bit of wind is nice. A lot of wind is not. Right? You're picking up a concentration in the air of methane. So if the wind's too strong and it dissipates, that plume starts getting smaller and smaller, and now you're like, it's just a dot, and it's starting to have. Got a little wind, becomes an arrow. That's where you're from. If you have no wind, ball, circle. Action. Yeah, good question. I was hoping somebody here could tell me that. I assumed it was on guessing. I'm like, everyone knows. Excellent question. Yeah. Okay, and that's the end of back to